Good morning or good afternoon, as the case may be. My name is Sosale Mohana. I'm a maths teacher who has taught maths for over 50 years in 3 continents and 3 countries, like India, in Asia, Kenya in Africa, and England in Europe. I've just retired a couple of years ago, and I thought I should use my experience to record and deliver a number of lessons based on the British curriculum for A-level maths, so the students who want to reinforce their learning can use it. I have a master's in maths, of course, way back in 1969. I completed my master's in maths, and then I did my teacher training in 1974. I've been working since 1969 till 2019, clear 50 years. So I hope these lessons are useful to you, and you're welcome to watch them, and then with each lesson, there will always be a document which covers whatever has been done in the lesson, so you could use that perhaps as your own notes, or maybe to go over what has been taught during the lesson. I hope you enjoy the lesson.
Today's lesson, I am more interested in what you call rational functions. These are, now we are into the realms of A-level. Rational functions. Graphs of rational functions. That is what I am more interested in. But please don't forget the quadratic. I have taught you now the other way of completing squares. The handout of this will have 2 examples. One when x squared has a positive coefficient, and one when x squared has a negative coefficient. So, to understand this, what's a rational function? Y is equal to f of x over g of x, where f of x and g of x are polynomials, in x. A polynomial, I think I had mentioned before, if not, something like it's the sum of a number of terms in x. X power 4 minus 4x cubed plus 6x squared minus 5x plus 7 is a polynomial. X plus 3 is a polynomial. The order of a polynomial is the highest power of x. So if it has x power 4, it's a 4-degree polynomial. A quadratic without the 0, a quadratic function is a 2nd-degree polynomial, and so on and so on and so on. Polynomials in x. Again, we will not go beyond power 2. So, I'm looking at y equal to 1 over x, y equal to x minus 2 over x plus 1, y equal to 1 over x minus 1, etc. Or y equal to x over x squared plus 2, or y equal to x squared minus 1 over x squared plus x squared minus 4, something like that. So many things. And how to sketch graphs of curves like these. I won't do all, I'll show you some important points, but let us take a simple example. The graph of y equal to 1 over x. If you put x as 0 in your calculator, it comes as a math error. And your teachers have told you, you cannot divide by 0. I will have told my students, don't divide by 0. You can't divide by 0. It goes to infinity. Why is it going to infinity? Why should suddenly, when you divide by any other number, it's a nice small number, whereas when you divide by 0, it goes to infinity? Are we crazy? To understand this, what we'll have to do will be, look, that means when x equal to 0, y is 1 over 0, which is not defined or undefined. But then we must get an intuitive idea of what happens as we come to 0. So if I have the number line, the x-axis and the y-axis. So I have this as the x-axis, that as the y-axis, and obviously that is 0, that is y, that is x, and this is the line x equal to 0. To come to that value x equal to 0, I can move like this. values of x, or I can move like this. That means either I can move from x minus or I can move from x plus. Let's see what happens. I'll just list some values. Y equal to 1 over x. Say when x is minus 1, y is minus 1. So that's minus 1, that's minus 1. Brilliant. I'm moving towards 0. So x is minus half, y is minus 2. So at minus half, I'm going to minus 2. When x is minus 0.1, y is minus 10. Look, minus 0.1 is somewhere there, and minus 10. X is minus 0.01, y is minus 100. So if I take that one, it's going somewhere there. X is minus 0.000001. So small, I'm coming close and close to 0. Y will go to 1.1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That will be 10 power 7. 10 million. Ooh. So, in other words, as you approach 0 from the left or from negative values, your graph seems to go in the negative direction. Bigger. But x can never be 0, y can never be infinity. In other words, the graph will never ever cut the line x equal to 0. Do you realize that? The graph will never ever cut this line. Remember, they're not parallel. They're not parallel. Parallel lines, the distance is the same. Here, distance becomes smaller and smaller and smaller and smaller. As in other words, they put it. In mathematics, we put it in a lovely way. It's a paradox. At the same time, it makes sense. It is, you can make the gap between the graph of 1 over x and the line x equal to 0 as small as you please. But we don't stop there. We make it more interesting. We say you can make it smaller than the smallest number you can think of. Can you imagine? The gap between them can be made small. If you say, I want the gap to be 10 power minus 42. By taking a value of x, 10 power minus 43, I can make the gap still smaller. So, the gap between the graph of 1 over x and the line x equal to 0 for negative values of x can be made smaller than the smallest number you can think of. Amazing. So therefore, or you can choose a small value of x as close as you want to 0 and make y bigger than the biggest negative number you can think of. It's a funny concept, but that's what infinity is all about. Bigger than the biggest number, smaller than the smallest number in the negative direction. In fact, there is a saying once. In fact, my professor told me this when I was in the college. Some student asked him in the class, "Sir, what would happen if I were to the volume of what would happen?" Sorry, he said, "What would happen if I were to add 2 to infinity? What is 2 plus infinity?" The teacher replied, my professor replied promptly. He said, "Look, take a cup of water, add it to the ocean. Would it make a difference to the volume of the ocean? No. So it doesn't make a difference whether you add 2 to infinity. It's still infinity. Like adding a cup of water to the ocean, still the volume of ocean is so big, so infinite." Anyway, coming back to this. So it looks as though the graph of y equal to 1 over x goes to negative infinity as x approaches 0 from the negative side. That means as x is negative and increasing. But as I told you, I may come to x from the positive side. So let's start with x equal to 1. When x is 1, now I'm going to make it plus 1. That's plus 1. y is 1. X is plus half, y is plus 2. X is plus 0.1, y is plus 10. X is plus 0.01, y is plus 100. X is plus 0.00001, y, that's what you see, that as you approach, as the function 1 over x, as the values of x approach x equal to 0 from the positive side, the values of y will keep on increasing. So the graph seems to go up and up and up and up and up. But it's something very interesting. You should look at positive and negative as directions. So in other words, if you're standing and watching, so let's say you're standing at 0 and watching this particular graph, a car move away in the negative direction, you watch, and when you are standing here, you're watching the car going behind you all the way. But you stand there, suddenly you see the car coming the other way. So it's as though, it's as if, it's a fantastic imagination. It's as if when you move from negative to positive, or when you cross 0, the graph crosses an infinity. It was going to negative infinity, comes back from positive infinity. So if you go further, the graph will come down like that. So in other words, here I am. Let's assume this is negative, this is 0, this is negative, that is positive. So I'm standing here, there I'm seeing it's going down, oh yeah, it's going down there. I suddenly move this side, it's coming up from there. Can you imagine something that was going down suddenly starts coming up? This concept, if you watch some of the old Laurel and Hardy movies, you will see, especially I think one of those where they were construction workers, the policeman is standing there, Laurel is carrying a plank of wood on his shoulder and is walking. And the policeman is wondering, oh, suddenly the plank at the other end again, Laurel is carrying the plank this way and is confused. So in other words, it's as though he was going this way and suddenly he's going back the other way. And at the other end, which is strange. So therefore, such a point where the graph jumps in infinity is a point of discontinuity. Discontinuity means, remember, imaginary function is not an imaginary function, it is a real value, but something infinity, something not definite. So a point of discontinuity is where the graph, how would I put it? The graph jumps in infinity, or it's a gap there. It's not defined. And in this case, we say the line x equal to 0 is an asymptote. A word which you will have heard. Asymptote. And because it is parallel to y-axis, it is called a vertical asymptote, or we use a short form VA. Vertical asymptote. So at a vertical asymptote, the curve jumps in infinity. So it starts from, if it is going towards one infinity, then it starts from the other infinity. So it's a point of discontinuity, and the function y equal to 1 over x is not defined. So therefore, that's the reason why you always see the domain x belongs to R, x not equal to 0. So whenever you give a domain of a function, you must always indicate the points where your function is not defined. So then that's one. Let's continue with the same thing. What happens now if I allow x to go to negative infinity? So x is 10, minus 10, y is minus 0.1, x is minus 100, y is minus 0.01, x is minus million, y is minus 0.000001. Did I count 6? 0.00001. Yes. So x is minus 10 power 40. Y will be 0.39 minus 39 points. In other words, as you move towards negative infinity, as x decreases towards negative infinity, the value of y approaches y equal to 0. But again, it will never be 0 because x cannot be infinity. So this graph goes like that. Again, on the positive side, as x is 10, y is 0.1, x is 100, y is 0.01, x is 1000, y is 0.001. So as x goes to positive infinity, y approaches 0. Y will never be 0 because if you say 1 over x equal to 0, you get 0 equal to 1, which is rubbish. So therefore, it cannot be 0. A fraction cannot be 0 if the numerator is not 0. And the denominator cannot be 0. So therefore, you can see this particular line x equal to 0 is also an asymptote because the graph tends to infinity. So the definition of an asymptote in short is, remember when a curve touches a line, it's a tangent. This curve is going to touch the line x equal to 0 at infinity. This curve will go to the line y equal to 0. Sorry, this is y equal to 0. Y equal to 0 at infinity or x equal to 0 at infinity. The lines x equal to 0 and y equal to 0 are tangents at infinity to the curve, and they are called asymptotes. So anytime you have a rational function or a rational expression and you have to sketch the curve, the first thing you look for is the asymptote. But that doesn't mean the other functions don't have asymptotes. But a rational function, there is a very high possibility it will have asymptotes. Okay? So in the next lesson, I will sketch, taking examples, some rational functions. Hello, I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.